All right, so you should have added all of these into your notes. Basically, what this is showing you is there's actually many different ways that a derivative can actually be represented. All of these are just different ways of representing what we've always used just f prime of x for. But all of these are also valid ways of describing the derivative. And I'm giving you this up front because you're going to be seeing these come up here and there. They're all just kind of going to be mixed together as you go through in your calculus work. You'll be seeing the prime notation like we've been using so far, but you'll also see stuff like this, like the dy over dx and all that kind of stuff. Alright, so starting into our new unit here, we're going to start with, hopefully, review. Hopefully these are easy questions to answer. The first one, we're told that f of x equals 3. What does f prime of x equal? So the derivative of 3 is 0. Let's try that again. There we go. What if g of x equals 7? What is g prime of x? 0. If h of x equals negative 5, what's h prime of x? It is 0. Because all of those end up being 0. A little bit of a reminder about why. If I were graphing any of these, remember the graph would just be a horizontal line. In the case of the first one, it's a line at 3. Here's a line at 7. Here's a line at negative 5. But all of them have a slope of 0 because they're all horizontal. And remember, the derivative means the slope. That's why all of our slopes there are 0. Now, you've actually taken notes on this before, but if you did not remember the answer to those questions, you might want to add this to your notes again so that you remember it. But as much as anything, this is also bringing back some of that different notation. Notice how they're writing our rule here. It says d over dx of c equals 0. And so that's saying the exact same thing as saying if f of x equals c, then f prime of x equals 0. It's just a little bit of a shorter way of doing it, showing that d over dx of c, that is the derivative of c, where c is just a constant, is always going to equal 0. Alright, so having just gone through that big investigation, you should have gotten this rule described in your own words. Now it's time to formalize it. So please write this down into your notes. Alright, so now we're going to be practicing the power rule here with a number of different problems, seeing them applied. Now, based on the work that you just did on the worksheet, this is hopefully easy, but I'm going to walk you through this first one just to make sure that we got this whole process down. Of course, write down the problem and the work we do. So I know what f of x equals, so I'm looking to figure out what f prime of x is going to be. And I'm going to show this out the long way. So I'm showing an extra step here just to make the work super clear. So this first one, it becomes 3 times the derivative of x squared. Well, the derivative of x squared, based on our power rule, is going to be 2 times x. It's just x because that would be x to the 1. We don't need to write x to the 1, it's just x. All right, then we do plus 2 times the derivative of x. But the derivative of x is just 1, so that's just a 2 there. And then the plus 1, well, it's a constant, right? And what's the derivative of 1? 0. And so f prime of x then, we can see equals 6x plus 2. So you just carry down that exponent and multiply it by the constant in front. Multiply it by your coefficient. Please practice that idea with both of these. All right, now let's go ahead and find each of these derivatives. So first up, f prime of x equals, so I carry down my exponent, so that's going to be 3 times the derivative, so that's n minus 1. So 3x squared minus 2. That's your final answer for that one. And for the second one, f prime of x equals 4x plus 7, 4x cubed rather, plus 7. So if we can do those, then we can now start tackling these, the ones that start getting a little bit trickier, a little bit messier. All right, so let's take a look and see how we go about doing these. The first one is set up in a way that's a little bit more comfortable to work in. So if I'm going to find f prime of x for this one, I'm again going to multiply by the original exponent, so that's going to be negative 5, times x, and take the original exponent now and subtract 1 from it. So negative 5 minus 1 is going to give me negative 6. All right, next part. It's going to be plus 2 times negative 2. Well, what's 2 times negative 2? It's negative 4. Now, because that's a negative 4, I want to turn that plus into a minus. I'm just taking care of that all at once. If you want to put it as a couple separate steps, just so you don't lose track of something, that's a great strategy. All right, so that was a negative 4, and then it's x. And then again, I need to subtract 1 from the exponent, so negative 2 minus 1 gives me a negative 3. Now, in this particular case, because our original problem was given with the negative exponents in there, we can go ahead and give this as our final answer. So this one is done. However, I want to show you where we could take it from here because it's going to help remind us how we tackle the second one there. And so, while that is correct as a final answer, I want to show you where else we could go. So for this negative 5x to the negative 6, the x to the negative 6 means like 1 over x to the 6. So that x to the 6 goes onto the bottom. Now the negative 5, the 5 does not have a negative exponent on it, so it just goes on top. And because it's a negative, I'd write the negative in front of the fraction. If you wrote it as a negative 5 over, it also works. It's just not quite as neat. All right, now for the next one, it's going to be subtracting. And again, the 4 goes on top, and the x cubed goes on bottom, because that's where the negative exponent's attached to, is it's attached to the x, so the x is what goes into the denominator. Now, seeing that tells us how to approach the second problem here, the g of x. Because if I'm going to find g prime of x, the very first thing I want to do here is take each of those two fractions and make them no longer fractions. So the 1 over x squared, that's just the same as x to the negative 2. And then the plus stays a plus because all I'm doing is changing forms here. And then the 5 that's on top multiplies by the x to the negative 3. All right, now once I've written that, then it should be just as easy as the first one, at least for this next step. And actually, I made a little error in my writing. Can you see where I made the error in my writing? Yeah, I wrote g prime of x, but I didn't actually do anything for taking derivative yet. All I did was just rewrite the fractions with the negative exponent, so it wasn't g prime yet. I'm glad I made that mistake, though, because I see that sort of error come up on a lot of people's work. When do I start using this notation or that? And so it's good for us to be reminded that I only include that prime notation when I actually start using the power rule. That is, I subtract 1 from that exponent and multiply by the original exponent. So this first term, the x to the negative 2, becomes negative 2 times x to the negative 3. And then it's going to be minus 15, because I did 5 times the negative 3. And then I subtract 1 from the negative 3 there to get an exponent of negative 4. Now in this problem, this actually is not going to be okay for my final answer, because in this problem I started without any negative exponents in there. I started with fractions. And so I need to put it back into that form with the fractions. So then g prime of x, it's still prime, because this is still representing the derivative, equals a negative 2 over x cubed, then the minus, and the 15 over x to the 4th. Next up, we're going to be dealing with the fractional exponents and the radicals. So write down both of these problems, or at least the first one. Leave yourself room to work if you're writing down both, because we're going to work through both of these together, because, of course, these were the ones that gave us the most trouble on the investigation. All right, so for our first one, for f of x, I'm going to find f prime of x. And I can still do it using the power rule. So that is, I write down whatever my original exponent was. So that's my 1/2. And then I do x to the power of that original exponent minus 1. Well, if I take 1/2 minus 1, I get a negative 1/2. Then I repeat the process for this second one. So plus, and now I do 3 times a third. Well, that's just 1, so that goes away. And then we do x to the power of, and now I do 1/3 minus 1, which gives me a negative 2/3. For some of us, dealing with the fraction subtraction can actually be one of the tougher things at this moment. If that's the case, you might make a quick note to yourself over here how we approach it. If I'm going to do 1/3 minus 1, well, let's go the long way. I'm going to turn that 1 into a fraction, 1 over 1, which I can then get as a common denominator of 3, so that becomes 3 over 3. 1 minus 3 on the top is 2. And, of course, we need a common denominator because it stays the same. So if you've been a little rusty on that, make note to yourself so that you can remember how to do those. All right. Now, having done that on f prime of x, that's fine as our final answer in this case, because we're just given fractional exponents at the start. But I'm going to take it a little bit further yet again to show us how can we clean that up, because this process is actually probably the hardest process for many of you at this point. So f prime of x is going to equal, I'm going to start by just dealing with the negative exponents. So the negative exponents move those pieces into the bottom. So for this first one, it's going to be over x to the 1/2. Now the 1/2 that was out front, that becomes a 1 on the top and a 2 on the bottom. So it's 1 over 2 times x to the 1/2. All right, then for the next part, we still have our plus, and this is going to be 1 over x to the 2/3. Again, the negative exponents just moving them into the bottom. Now again, continuing to show how would we deal with this. Now I take each of those fractional exponents, and I'm going to turn those into radicals, because remember, a fractional exponent is just the same as a root of some sort. So this first one becomes 1 over 2 times the square root of x. Notice the 2 does not have the power of 1/2 on it, so the 2 is not under the radical, only the x's. Then the plus 1 over, now x to the 2/3, remember whatever's on the bottom, that's which root it is, so this is the cube root. And then the number on top, that's the exponent inside of the radical. So it's the cube root of x squared there. If we were trying to give our answer with the radicals in there, this would be looking pretty good. Although we can actually go even one step further. And this is where things get really hard for many of us, because I can rationalize both denominators. And so, in order to rationalize both of those denominators, I would multiply top and bottom of the first fraction by root x, which would give me root x over 2x. Plus, now this is the tricky one. For the second one, I'm not going to multiply top and bottom by the cube root of x squared. Because if I did x to the 2/3 plus x to the 2/3, I'd get x to the 4/3. I need x to the 1. And so I'm actually going to multiply top and bottom there by the cube root of just x. So it's cube root of x over just x. Now, aren't you glad you didn't have to do that on this first one? Although, if you wanted to get a little fancier, you even could. You could even make that into a single fraction if you wanted to. There's all sorts of other little things we can do in terms of the cleanup. But of course, we don't have to do many of those things. I'm just wanting to show you how it can be done and what can be done, so that later on, when we do get to the point where you have to, you'll have at least seen it a little bit more often. All right, now for the second one, if you haven't yet written down g of x, write it down now. We're going to walk through that one together. So the first thing I want to do in terms of figuring out this derivative is I'm just going to take those radicals and I'm going to write them as fractional exponents, so that this problem looks a lot more like f of x, which means that I'm going to have 3 times x to the 1/2 plus x to the 2/3. Now that I've done that, I can now go to finding the derivative, because I've now made it just x to the power of something plus x to the power of something. And so now we're going to go to g prime of x, because I'm now going to the derivative. And so for this first one, I'm multiplying the 1/2 by the 3, so that's going to give me 3/2 times x to the power of, now I do 1/2 minus 1, which gives me a negative 1/2. Plus, multiply by the original exponent, so that's going to be 2/3, times x to the power of 2/3 minus 1. Now 2/3 minus 1 should give you a negative 1/3. That right there is our derivative. We found g prime of x. So in terms of what we learned new today, this is what I expect you to be able to do. Now, in terms of being able to push ourselves a little bit more and see how do we deal with these annoying radicals and the negative, fractional exponents and all that kind of stuff, I'm just going to keep working to clean it up a little bit, show us how we can go about doing that. So this makes for good notes as much as anything. So next up, g prime of x equals 3 over 2 root x plus 2 over 3 times the cube root of x. So notice the negative on each exponent is what told me that the x went into the bottom. And then 1/2 power is square root, and 1/3 power is cube root. And then for the fractions that were out front, the 3 on top goes on top, and the 2 on bottom goes on bottom. All right, having done that much, you've done really well. We could continue to rationalize our denominators though. And so let's see what that would look like. So we got g prime of x equals, now I'm going to multiply top and bottom of the first fraction by root x. That will give me 3 root x over 2x. Plus between them. Now on the second one, what makes it tricky is that if I multiply the cube root of x by the cube root of x, all that gives me is the cube root of x squared. It does not give me x on the bottom. I actually have to multiply top and bottom by the cube root of x squared. Because if I multiply that cube root of x on bottom by the cube root of x squared, it gives me just x. And so for the full rationalizing the denominator kind of work, that's what we end up getting. So now we're going back to some problems we were taking a look at earlier, the basic polynomial derivatives. And we now start saying that since I can take the derivative so easily, it's probably not really out of the realm of reasonableness to be able to now also figure out the second derivative. And that's what we can see with this notation is, I see f of x, I see f prime of x, and then I can go to f double prime of x, which means the second derivative of f of x, which actually in these cases is nice and easy. Because if f prime of x, looking at this first one here, if f prime of x equals 6x plus 2, I just take the derivative of that. What is the derivative of 6x plus 2? There you go. Is that so bad? All right, so for the next one, the one next to it here, so I'm now going to, in order to find the second derivative, I just take the derivative of 3x squared minus 2. You should have gotten 6x there. And then for our last one, f double prime of x there, you should be getting 12x squared. And that's it.